I am back with page 34 in the exercise book, and we're picking up with the next problem. Page 34, we're looking at number 16. Tyler claimed that all factorials are equal to even numbers. Which factorial proves that Tyler's claim is incorrect? Well, 9 factorial is huge. 362880. This one ends in 0. That's an even number. Even numbers are 0, 2, 4, 6, 8. So that one does not prove Tyler wrong. 8 factorial. 40,320. That's an even number, so that does not prove Tyler wrong. 5 factorial. I know that one from memory. That's 120. That does not prove Tyler wrong. 2 factorial is going to be 2. That's an even number. So maybe Tyler's not wrong. But then 1 factorial is 1. And that is an odd number. That's the one that proves Tyler wrong. E as in echo. Number 17. Which expression shows the number of ways to choose a pitcher, a catcher, and a batter from among 7 players? A pitcher, a catcher, and a batter from among 7 players. So this is a little bit different type of question than the ones we've seen so far. But this is a little bit a different type of skill. This is about permutations. So, a couple of ways I can show you this. If you recognize it's a permutation, that's one way. Let me look at the choices. That's the permutation formula. So let's go at it that way. And then I'll show you another way that I haven't shown you before. But let's get this first. The permutation of NK is n factorial divided by n minus k, factorial. So n is the number of players, that's 7, and we want to choose 3 positions from that. So we would have 7 factorial over n minus k, that's 4 factorial. And if you work this out with the calculator, you're going to have 7 factorial, which is 5040, over 4 factorial, which is 24. And that's going to be 5040 divided by 24, which is 210. So we have to choose from these choices. And I'm going to go with A because that fits what I did right here. Let me do it this way. This is going to be 7 factorial over 7 minus 3 factorial. And that does match up exactly to A. So I want A as in alpha on this one. But I do want to show you something here. I want to expand this just a little bit right here. Draw yourself a big old fraction bar. And on the top, we're going to put 7 factorial. So we're going to say 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, we're going to put 7 minus 3 factorial, which is 4. So we have 4 times 3 times 2 times 1. And here's what I wanted to show you. You can cancel top and bottom as long as they're identical. So this 4 times 3 times 2 times 1, I can cancel on both sides. And then you could say 7 times 6 times 5. And guess what it's going to be? 210. And I hadn't even thought of showing you that until I saw these answer choices. And that made me realize I haven't shown you how that formula actually works out mathematically. So at some point, you have to divide in this permutation formula. Okay, number 18. Let me put it right here. How many different parades can be made by lining up 5 available floats? Couple of ways you can do this. I'm going to do it first with the formula because you have 5 floats and you want to use 5 floats. Let me say it that way. So you can do the permutation or you can just do 5 factorial, either way. But let me go ahead just for practice and do the equation here. So you have 5 factorial over 5 minus 5 factorial. So that's going to be 120 over 1, or 120. You could also just have done 5 factorial to start with, because remember, when n and k are the same number, it's the same as just doing the factorial. So either of those methods would have worked here. I want 120, and that looks like B as in Bravo. All right. Number 19. The pin on your suitcase lock is 3 digits from 1 to 9 with none repeated, but you've forgotten the pin. If you can try one set of 3 digits every 5 seconds, what is the longest time it could take you to open the lock? All right. First of all, we need to figure out the number of possible combinations that there would be. And to do that, you can use a permutation, because with pin numbers, the order matters. If your pin is 685 and you type in 568, it's not going to work. The order matters. So let's do the permutation of NK. And let's say that the number is this how, let me think, guys. Is this how I want to do it? Why would I not just do non-factorial? No, I'm going to follow this through. Okay, so 9 possible numbers, and you have to have 3 of them in the right order. So this is going to be 9 factorial over 9 minus 3, that's 6 factorial, Let's go ahead and use the calculator. If you didn't have the calculator, you could do it by canceling, but we do have the calculator, so let's do it that way. So you have 362,880 over 6 factorial is 720. So let's do that division. This is going to give us the number of possible combinations. There are a lot of them. 504 things that you would have to try, 3 numbers at a time in a specific order to get your lock open. I hope you have some time because it's going to take a while to do that. But we need to figure out how long. If you can try one set, let's call these sets, every 5 seconds. So here, I'm going to use a proportion to do this. We learned that in this chapter as well. So this will work for me right here. We can do one set. Remember what ratios do. They compare two quantities. So I can do one set every 5 seconds. And I have to test 504 sets. So 504 times 5 is 2,520 divided by 1 is 2,520 seconds. But my answers are not in terms of seconds. So I'm going to do another proportion. They're trying to kill us, guys. They really are. Of seconds to hours. Well, we'll have to do seconds to minutes first, I guess. So there are 60 seconds in 1 minute, and we want to convert this many seconds. So multiply the peanut and divide by 60. I typed in 52. Good old dyslexia. 42. This is minutes. So let's see if this is one of our choices. Oh, it is. It's C. I thought I was going to have to go on to hours, which would be another proportion, but I can do it. You can do it. But we don't have to. We've got our answer. I believe 19 is C, as in Charlie. Anytime you have to convert, that proportion will work. You don't have to use a proportion, but it helps me to stay organized in what I'm doing. Number 21. No, number 20. You are directing a historical play. In how many ways can you cast the roles of Washington, Adams, and Jefferson from a pool of 8 actors? Okay, so we're looking at a permutation here where we have the number of actors and the number of roles. So the number of actors are 8, and we're going to cast 3. So this will be 8 factorial over 8 minus 3. That's 5 factorial, which is going to be 8 factorial, 40,320. And 5 factorial is 120. Go ahead and divide those numbers, and you get 336 possible combinations. And so I like D as in dog or delta for that one. Number 21. How many different ways can Amos, Bill, Chuck, Deborah, Esmeralda, and Florence be arranged? There's the clue. This is a permutation for a photograph with the men on the left and the women on the right. Okay, so it's not just a straight up permutation. We have to classify the men and the women. So the men are Amos, Bill, Chuck, and the women are Deborah, Esmeralda, and Florence. And I suspect that the alphabet, these are in ABC order. That's probably to help us organize if you choose to go that route. Okay, here's what we have to remember. They want the men on the left and the women on the right. So they want the men on the left and the women on the right. So we have to figure out two permutations here. Let's move this over just a hair. So for the men, you have the permutation of N and K. So we have the number of men is 3, and the number of positions is 3. Because remember, we're just putting the men on the left. So we can do the formula, or we can just do 3 factorial here. And 3 factorial is 6, I believe. Yes, 3 factorial, 6. Okay. Same with the women. You have 3 women. And you have 3 positions to fill. So 3 factorial, or you can do the whole formula, it'll come out the same, is 6. And then we have to put them together. We have to take the men and the women and put them together. Now, what does the word "and" mean in this type of problem? It's multiply. Okay? So you have 6 different ways to put the men together, and you have 6 different ways to put the women together. And 6 times 6 is 36 ways to put them both together. So I like answer B as in Bravo for this one. That was a good question. We haven't seen any like that. But remember, this is an exercise book. They're making us use those muscles. All right, number 22. There are 380 ways the Springfield